because these amines are basic, so acid-base reaction, it will result in a formation of a salt. And if we have a mixture of weak alkali and its salt, we call that as a buffer solution. So basic buffer solution can be formed by mixing amine, ethylamine or methylamine with ethyl ammonium chloride or methyl ammonium chloride. Formation of a complex, as we studied earlier in transition element, that if we add aqueous ammonia or if we add sodium hydroxide, the first reaction is basically an acid-base reaction in which the aqua complex loses proton and the other substance accept proton. So if we add ethylamine to an aqua complex of copper. So first what happens, this copper, it tend to lose protons. So this complex is acting like an acid and this substance is acting like a base. And what it formed, because there is a charge on the complex, so it does not form here precipitate. What it formed a colored solution. So lone pair of electron on the nitrogen enables amine to act as a ligand and form a dative covalent bond into a transition element to form a complex or colored complex. This is a similar ligand exchange that to the one where ammonia act as a ligand. So if we add ammonia, like if you are adding ammonia, first it will form a blue solution, blue precipitate in a small amount, and in excess the precipitate dissolve and it will form a deep blue solution. Same thing happen first if we add a small amount of ethylamine, it will form blue precipitate, but this reaction, this equation is given for excess. So when we add an excess, so ligand exchange occur, amines are added or ethylamines are added, replaced by water molecule. Is it clear?
Yeah.
So copy this part as well. Next, the reactions of primary amine with halogen alkane, and what they can form as a result, they can form a secondary amine. So amine will react with halogen alkane in a similar way. That's a reaction of ammonia with halogen alkane. It's a nucleophilic substitution reaction. This, if you remember, you did in AS chemistry. If I write the overall equation, because nitrogen is more electronegative, so nitrogen will be partial negative. And in this nitrogen, NH2 or two hydrogens are there. So basically the bond is not evenly distributed. One of the hydrogen electron pair is almost shifted toward nitrogen. So one is completely positive, almost complete positive. We write a symbol partial positive because it shows still there's a bond between them. And in alkyl halides, so CH3, CH2 halogens are more electronegative as compared to carbon. So this will be partial negative and carbon chain will be partial positive. So the whole carbon chain will take position of hydrogen. So as a result, already one carbon chain is attached. The second carbon chain will also attach with nitrogen. And plus HX will be there. So how the reaction occur, how they form, or the mechanism for this reaction. It's a nucleophilic substitution reaction. So if we have halogen alkane, if I draw the structure of CH3, CH2 and Br. So attached to this is CH3, CH2, Br. This is partial positive, this one is partial negative. And this nitrogen, because it's having a lone pair, so this lone pair of nitrogen are actually attracted towards the partial positive side. So attacking on the nuclear electron deficient side, That's why we call them as nucleophile. So once it will form a bond, so it will be R, N, R, H, because nitrogen donated the electron. There are two electrons, a lone pair of electron on nitrogen. So nitrogen donate one of the electron to carbon and then form a bond with carbon. So as the nitrogen completely transfer the electron to carbon, so nitrogen will get a positive charge. And there is H, and Br is there. Then after that, because this bromine will take both of the electrons, so bromine will go out and there's a bond between carbon and nitrogen, but nitrogen is having a positive charge. Why? Because nitrogen donated one of the electron to carbon and then form a bond with carbon. So to gain the stability, nitrogen will take the electron from hydrogen, and again the nitrogen will have a lone pair. So this will be CH3, H, and H. So you can see here another carbon chain is attached to nitrogen. So if it's a primary, it will turn into secondary, and if it's secondary, it will turn into tertiary. So this is a mechanism for this reaction to occur. The secondary amine form can also react with more halogen alkane to form tertiary, and subsequently a complement, basically the four carbon atoms or carbon chains are attached to nitrogen. So we call that as quaternary ammonium salt. So if we have limited amount of halogen alkane, limited amount of amine like this ethylamine or methylamine, then this will result in a formation of multiple substitution. Is it clear, the mechanism and the reaction of primary amine with halogen alkane to form secondary
Yes.
amines? This is important. Copy this. This one is a mechanism for this reaction shown. So if they ask mechanism, you should be able to show the mechanism for this reaction. Reaction with primary amines, reaction with of acyl chloride as well. Acyl chloride with primary amines. So if we have acyl chloride, example C double bonded with O and Cl, that is acyl chloride or ethanyl chloride, it reacted with amine. So what will be the result? This will lead in a formation of amide. So how the amide will form, because this one is partial positive, carbon is partial negative, and in this case carbon chain is partial positive, chlorine is partial negative, and carbon is positive, and in amine carbon is partial positive and nitrogen is negative. So this NH2 will take possession of Cl. You don't have to learn the mechanism for this. So reaction occur, a substitution reaction, which lead in a formation of N. Why N-methyl? Because methyl group is there, that's why N-methyl. And why H? Because there are two carbons, so H, they have a single bond N, and due to this functional group, we call that as amine. So change in functional group, if acyl chloride, we want to convert into secondary amine, so at room temperature, we can add amine, and this will give us the final result. This is how a paracetamol is made. So paracetamol is made by reaction of aromatic amines with acyl chloride. The same way the reaction occur. So you can see here, this is the same concept. We have 1, 2, 3, 4, or we can count 1, 2, 3, 4. So it's 4 hydroxy phenylamine. And if we add an acyl chloride to this, so the amine group will lose its hydrogen and the acyl group is attached to that. So you can see here one hydrogen is removed and acyl group is a C double bonded with O and CH3 group is attached. This is the formula for a painkiller paracetamol. Is it clear? This formation or reaction of acyl chloride with amine, primary amines to result in a formation of amides. So this paracetamol also C double bonded with ONH. It also contains paracetamol is a common name. It's not the IUPAC name. So C double bonded with O and N is there. So it can also contain amide groups. Any doubt in this? You have to learn. You don't have to learn the mechanism for this. You just have to learn the product which is formed by this reaction. Is it clear?
Yes.
The term reduction means it's addition of hydrogen or removal of oxygen. So the nitro group of arene can be reduced to amine group. How? By reacting tin and hydrochloric acid or iron and hydrochloric acid. So what it will produce when tin reacted with the metal react with acid, it will give salt and hydrogen, or it will have a nascent hydrogen, freshly prepared hydrogen, and that nascent hydrogen will react with nitrogen, so it will remove oxygen. So nitrobenzene will convert into phenyl amine. So as the reaction is carried out in HCl, the salt is there, C6H5, NH3Cl is formed. And reducing this salt with sodium hydroxide will give a phenylamine. So directly phenylamine is not formed. Initially what happened, if you check the substance like ammonium salts, so ammonium salts on supplying heat energy, they decompose into ammonia and HCl. So same way the reaction occur here, that when we add the tin metal with hydrochloric acid or iron with hydrochloric acid, so this oxygen is replaced by hydrogen, but directly phenylamine is not formed. So what is the initial product? So it will be a salt, NH3 with a positive charge, because when nitrogen form a 4 bonds, so how the nitrogen belongs to group 5. So as nitrogen belongs to group 5, it will have 5 electrons in the outermost shell. So it can form only 3 bonds in that case. But if nitrogen lose one of the electron out of this lone pair, if one of the electron is lost, so nitrogen will have a plus charge and it will form 4 bonds. So you can see here one of the bond is formed with benzene ring, and then remaining 3 hydrogen and nitrogen will have a plus charge, and there is Cl minus because we use hydrochloric acid, so which contain a chloride ion. And reacting with this salt with sodium hydroxide, if we add sodium hydroxide, the sodium hydroxide will remove one hydrogen and chlorine from that. This will result in a formation of phenylamine. The phenylamine formed in this reaction is best separated from reaction by a steam distillation. I will discuss steam distillation next class. So how we separate this phenylamine is by steam distillation. This whole process you have to learn, like how to separate an organic substance. So I will end at this point, reduction of nitroarenes to aromatic amine. Copy this one. Any doubt related to today's class? Steam distillation I will explain in detail because that's a chemical process which is used to separate the phenylamine from the mixture. And it's not like directly steam distillation is done because it involves different steps. So I will discuss all the steps of extracting phenylamine. So formation of phenylamine is different thing, but extracting or separating phenylamine is a whole chemical process which you have to learn.